We will have Vindev Oudit as our guest speaker. He will give a talk about careers in research. Now I will let Vindev to give his talk. So please pay attention. Thank you.
Yeah. All right. Thank you for the introduction, Hazel. Hi, everyone. So my name is Vindev. I'm a year two student at University of Manchester. I do maths with finance, and I have a keen interest in the topic of applied mathematics, particularly in line with statistics, probability, and also largely with computing as well. I quite like the whole programming. So over the last vacation, I was thinking to myself, how could I get involved? How could I, you know, put out a project of my own in this area? So funny enough, my home country of Trinidad and Tobago, as you can see in the background, um, held a general election, which is just like the UK election or whatever. We follow the same electoral process as countries like the United Kingdom and most countries in the Commonwealth. So um, I thought to do a project on that, on looking back at some past elections and doing a little analysis of the results and what could be inferred by a lot of these results. So what I specifically focused on was in our 2007 general election, there was a splinter third party group. Now, our elections tend to be dominated by two major parties, very similar as it may be in the UK, where it's mostly the Conservatives and the Labour Party. Now you have these smaller parties, but they very rarely ever will win an election. So in 2007, that was the closest Trinidad came to having a third party, so to speak, come and win our general election. So you might think of it as something like the Liberal Democrats winning in the UK election. So in this sense now, what we decided to do was analyze a different election system to the current system implemented in Trinidad and Tobago, which is also the one implemented by the UK, which is called first past the post. This different electoral system would be called proportional representation. It's a method whereby the votes are held in rounds, like stages. So if there are three parties, what they do is you as a voter, you list your top two choices, and then when the votes are tallied for the first time, you count up however many people had this party as their first choice, and the party with the least amount of votes gets eliminated, and all their votes get transferred to their second choice. So in this way, it can swing. I'll show you an example shortly, and that is the principle we were operating on. Now, if we could use this to see if it would benefit or hurt a third party's chances of winning a general election, and if so, what are the areas they need to focus on? How close were they, or could they have been? And should we be calling for something like this? So that was the general goal and aim of the research project, and I was able to accomplish it with fairly limited resources in about a month's time. So actually, let me just get into it. One moment. Okay, so well, this was the little cover of my little presentation. So as the name suggests, it's a third party problem, why they struggle in the current election system and how an alternative election system may benefit them. So just a little background. So we had a a party gained 22% of the national vote, but gained 0 seats, so to speak, in the House of Representatives. Now, of course, this seems kind of lopsided. So as a result, we went and we looked at how we can adjust that. So I start off here with just a little background. So this is just a little example of how proportional representation would work. So in our current system, let's say there are 3 political parties, and party A gets 3,000 votes, party B gets 2,500 votes, and party C gets 1,200 votes. Now, as you can probably tell, party A would win because they had the most votes out of all the 3 parties. That's our current first past the post system. However, under proportional representation, and to be specific, the method of the different methods, the one we're referring to is single transferable vote, which appears to be the most popular. So under this representation system, what we would do is actually eliminate party C. So now all 1,200 of these votes will be divided between party A and B depending on what the voters of C had as their second choice. So party C would be eliminated and you'd have a second round of tallying take place with party C's votes transferred. So suppose now 900 of them voted for party B. Let's say party B and party C are kind of close in ideology. So now you have 900 of the people who voted for party C choosing party B as a second and only 300 for party A. Under this system now, you'd have party A getting 3,000 plus 300, which is 3,300, and party B getting 2,500 plus 900, which is 3,400. So in this case now, party B gets the seat due to the change in the ratio of the votes of party C. Now, of course, if you were to adjust it slightly more back to party A, they would still win. If the split was instead of 900, 300, if it was 800, 400, they'd win. However, what we see is that it is possible for election results to change and possibly change dramatically depending on how it goes under a system such as this. So, obviously, when you're modeling a problem mathematically, particularly statistically, you need to make a lot of assumptions, right? You can only analyze certain things, and you need to clearly state your assumptions. And I would say that's always something. If you're trying to do a little project, you need to be upfront with your reader about what you're assuming. In that case, it protects you from being considered, well, of course, from just saying assumptions. So for the feasibility of the project, I made these assumptions and I clearly stated them here. So I just want to go through them with you. So just to get an idea. So I assume that the 2 major parties, people who vote for them, would have rather seen this third party win than each other, in the sense that a voter, if I was going to vote for, well, so it's a red party, the yellow party, and this third party, let's call them that, right? So if I was a red party voter, my voting order would be red party, then third party. If I was a yellow party voter, it would be yellow party, then third party. So in both cases, I'm picking the third party over the opposite colors party. And then what we're also assuming is that under this system, you might get additional voters, because the idea when you vote for a third party is that you may waste your vote because they don't have a chance. But under this system, that's not the case. Because your vote transfers, you don't need to worry about that. So we're assuming that there's possibility that the voter turnout and voter stuff like that may have increased. And that's generally the main gist of what we're doing. So I retrieved the vote tallies from both the 2007 and 2002 election just as a reference. But for the 2007, the algorithm for which I calculated was I would take the minimum of the votes, and if the party eliminated, so to speak, was the red party or the yellow party, all their votes would transfer to this third party, and then we'd retally the votes in that second round. So as you can see, the initial results were 26-15-0 to the third party. It ended up being 25-14-2 for the new system. Now, that is, of course, very, it appears to be a minute change, but in significance, what we see is that this is just under the assumption that they that there were no change in the voting patterns as a result of the system being in place. And it would be reasonable to suggest that there may have been that change. So I've just tabulated it here, and I'll show you how I calculate. That's probably the more fun part, how I calculated and was able to retrieve all this information without much time. So I measured the 3 seats that we're able to change. And of course, so this is like a map of the first round. So we see that actually our third party here becomes eliminated. And then, however, what we see, now this one in particular, I was going to adjust because this while it is, so to speak, this is what would have happened under the assumptions of the model. In this particular, very particular case, there were some other factors that may have affected it. So, but moving on now to something like this one. This is actually where the leader of the third party was contesting. So you can see they picked up a very large number of votes. The red party were eliminated. But we see now when we transfer it using our new system, they overtake them, and they overtake them greatly. Now, I'm going to go into how I was able to plot all of these graphs, because there are 41 seats, so I had to do this 41 times. And the system I used to calculate the results and the graphs were all intertwined in one nice little program, and I will go through that very shortly. And then we see it happened again. So what I also did was look at areas where it became close due to this. So we see here, and you can analyze that. And I was able to calculate how many again would be needed. So we have this for a few of them. And then we also did cases where the third party were eliminated, but if they only needed a small portion of votes to catch up to the original second place, then they would not have been the ones eliminated, and they would have been able to overtake and win. So we just repeated that across the board. And of course, these graphs were very, they were a bit time consuming to program, but it ultimately speaking, it ended up being much quicker than manually going and trying to create 41 graphs. So, and then, you just had your closing remarks and your acknowledgements. In general speaking, this is more or less original. I didn't have to quote or cite anything besides the results of the elections, which are just from our own governmental websites. So as a result, and I also decided to leave an email contact for me in the event anybody, when they saw the publication, if there were any errors. So that's the general gist of it. If anybody, for any reason, would like to get to see the full presentation, you can just let me know, and I will be happy to share it with you. So now, just trying to figure out how to unshare my screen. Okay. Huh. Right. Sorry about that. So let me stop sharing. Okay, great. So that was just a general rundown of what I did, the research involved, the results at the end. So of course, if anybody would like a copy of that, please let me know, and I will be happy to send it to you via email or any other medium. So now I want to get into probably the more interesting part of things, which was the programming side of it, the calculation side of it. Of course, to sit down and to do everything by hand is, it's not very efficient. So, and I think this is possibly the most universally applicable method of doing it because, of course, you can do this now. This is the more applicable part of the talk because this can apply to any data set, to any project you want to do. So allow me to share my screen once more. And okay, great. So what we're seeing on screen here now, sorry. So what we're seeing on screen here now is the program I use to get this done. Now, I like to use Python. You'll find that a lot of people, a lot of YouTube tutorials and all that will lead you to Python for things like data analysis. It's just very, these libraries in particular I've used are very, very important. And this type of programming is called a Jupyter notebook. It's that's the environment we're using. If you install the Anaconda Navigator or the Anaconda IDE, which is how you would get Spider for everyone who does programming with Python as a course within university. Jupyter notebooks are just another section where you go instead of going into Spider. So if you have no interest in programming, you might get a bit irritated at this point, but I just want to show the power of the code and all that. So actually with Jupyter notebooks, you can execute code line by line. So if I actually would now, so what I did was import a library called Pandas and import a library called NumPy and MatplotLib. Now, or Matplot library. As you can probably imagine, Matplot library is about plotting graphs mostly. So what you may see, sorry, just need to adjust my computer. Right. So what you may see is that the program is divided up into these little blocks, and that is so like you can execute each block at a given time, and based on this, it makes it a lot easier to run the code. So let me run that first cell. So it's run. It hasn't done any output, so I'm just going to. So I have a Excel file with all the results, and I want to import that in. So I use pandas.readExcel. I'm able to read that file. Let me just show you what it looks like. So, and this is the great thing about Jupyter Notebooks. So you can see exactly what's going on in your code. So I have the results for the 2007 and the results for the 2002. And this gives me the full, well, basically, it's like a spreadsheet. It's like an Excel sheet, but it's a lot more powerful as to what we can do with it. And we're going to see that. So next, I also wanted to calculate like what was the voters for 2002, and I wanted to calculate who got eliminated. Let me run this cell, and let's see what these little changes I've made will do. So you see now we get 1, 2, 3 new columns, and we find the tally of the eliminated votes. And we can see here, 8603, 1224, 34, 64. We see that 1224 would be the one to be eliminated. So we know that this column, the key is the same. We were also able to calculate the split from the 2002, but you don't need to be too concerned about that right now. I had that there, but I ended up not fully going into it. It's not, the data wasn't as necessary as I might have thought initially. However, let's continue. And we see now that if let's this line, again, we're going to insert a cell above. Let's see that just to see. So we've now converted it. So we said if the eliminated portion is equal to the total in whatever party, we set it now to the name of the party. So we're getting rid of the numbers, we're using the name. So well, we see that here, right? So in this case, it was the UNC who got 1224 votes, and then they would be the ones to be eliminated. Likewise, across the board for all the other sheets. So now I wanted to set up how we can go about doing the calculation. So what I needed to show, what I need to calculate was if the eliminated party was one of these, the new votes for the COP would have been this. And this is generally what we're doing. So if depending on the eliminated party, we were calculating what the new votes they received would be. And I format them as integers because it is possible to end up with a rounding error if you're multiplying. And just to avoid that, I made sure they were considered as integer values, and we can see what's going to happen here. So that's exactly what we got. We got the new votes for all the parties depending on what happened. Now we're only concerned with this final column. These two columns weren't already considered later on in the project as it evolved. But so we're able to get a good calculation here as to how many new votes you're getting. And then now we did a calculation of the final winner. And this last section to get the proportional winner. And then we ended up with this. So what we see here, we got the final votes for each party, and then we took the maximum of this to get the proportional winner. And we took the maximum, the original votes to get the original one, the first part, the first winner. And I was able to set it so that if this was not equal to this, it would display whether it changed. And we see it here, as well as here and here, which are the two we were concerned with because this was the party we were analyzing, the third party. So based on that, we now have a table that calculates the whole proportional representation. And you can actually export this back as an Excel spreadsheet. So ELEC was the name of our data frame. This is called a Pandas data frame. To Excel, you set the name of the Excel file you want. And if you want the indices like here to be added in, I didn't want it, and then we display it to the user. Now again, I cannot overstate just how powerful something like Jupyter Notebooks is in doing something like this, because you're seeing exactly what's happening at every stage. So if you have an error, and there will be errors, you see exactly where and how it's going wrong. Based on that, you know how to adjust your code to suit. Now, moving on. Let's look at how we plotted graphs. Now, this is probably the fancy part. So we see here that I have for I in range 40. So we're looping over, well, 41 seats, right? 0 to 40. And I plot every single one of the so I'm plotting a bar. So I've set all of these to be plots of bars with the value, the numerical value as determined by the data frame. And I can set the color to be whatever I want. And I put the title to be the name of the seat, the name of the area. And then I put in a little legend on it. And I can actually save the figure with a custom name for the file. Now you can, I mean, this a little part here is a little excessive, but let's take a look about what if we were to do this. So let me copy that, save as below. And I shouldn't actually do it as a loop because we'll end up plotting graphs on top of graphs. So let's do it for when I is 0. And we'll see, and we can change the value of I to see what we get. So let's run this. So you see, just like that, instantaneously we have a graph. Let's set I to something like 3. And it's just looping through. It's getting everything as we need. Let me see, 40. So this is the last one. And yeah, it's as simple as that, you know. So you're plotting nice high quality graphs, and I mean they come out when you save them, they come out a lot nicer than that, as you could have probably seen in the actual PDF. So we're plotting graphs at lightning speed, and it's really easy. So let's take a look now about what happens if we want to do it for proportional representation. So what I did was copy the data frame and then get rid of some of the some of the columns that weren't needed, right? I just did that for ease. So I was able, I mean, the calculation algorithm here gets a bit on the irritating side. But we ended up dropping the columns we don't need, and this is what we ended up with. So we got the eliminated party, the 2 parties that remained, and the eliminated votes, and then what happened when they got the new votes. And this is what we did here. So if this was the eliminated party, we did this. If this was the eliminated party, we did that. We plotted, and otherwise, which would be the eliminated party was our 3rd party, we did that. And then now, well, this was just a separate calculation. So, and you can actually, so how I was able to get the stack graph, there's the function called bottom where you can actually add on, you can stack graphs using this little function here. So, so I've plotted like this, for example, and then I want to add on this part, but I needed to stack on top of this, so I put that to be the bottom. So generally, I mean, you can look up this on the MatplotLib documentation, but generally speaking, the general point I want to make is that, you know, Python, JupyterNotebooks, Pandas, and MatplotLib, as well as NumPy, but I mean, I didn't use NumPy in this, but it's useful for other things, are some of the best tools you can actually use when you want to solve a data analysis problem. And the results can be quite nice. You know, it works out very nice. It is not that difficult to learn. I'll actually, if you'd like, I learned it largely through using YouTube and Google. You can get YouTube tutorials very easily from if you just Google it. Really. That would be my first recommendation. There's a YouTuber called Keith Galley who does a lot of Python programming tutorials. I think I looked at his videos. I'm not sure if I pronounced his name correctly, so apologies for that. But if you'd like me to direct you towards any resources where you can learn pandas, feel free. I will be happy to share anything I can help you with both Pandas, MatplotLib, Jupyter Notebooks, all that stuff. Even if you want to learn Python, I think YouTube is the best teacher for these kinds of things. Just on a, if you want to do it as a self-study, if you're not looking to do it on a, if you're not looking to do it on a, sorry, I lost my train of thought there. If you don't want to do it in university, sorry, and you'd rather do it via the, how to say, the self-study method, of course, right? So actually, let me show you, you can as well use, so I'm just pulling up. So this is the actual guideline for Pandas, their official website. So you can see here they have a user guide, which is excellent. You know, you can look exactly how you handle all the data files and everything. Of course, this is if you're interested in programming. If you're not interested in programming, it may not be very nice. But I think as far as Pandas go, as far as coding goes, Python, Pandas, and MatplotLib have proven to be, at least for me, the best tools for tackling problems like these. So you can even see scaling to large data sets. So it's very it's very good for handling big chunks of data. I mean, it's not SQL, but it is still very good. So overall, I would recommend this, and I would also recommend MatplotLib. So you can see, I mean, the visualization I did was very basic data visualization. There's so much more powerful things that can be done. But yeah, that's generally what we need to do.